Hi, and welcome to Google's Open Source Live. My name is Mitch Connors. I'm a software engineer with Google working on the Istio project in areas of usability and user experience. Today, I'm happy to talk with you about how to get to know your mesh using Istio out of the box. So let's get started. We are going to talk about how to get telemetry out of the box with Istio. Prometheus and Grafana provide a great deal of insight into how your service is performing, as well as any issues you may be having. We're going to look at how to debug and follow traces with Jaeger, as well as how to improve on the out-of-the-box experience. We're going to take all of that and pull it together with Kiali, which is going to give us great insights into the way that our services relate to one another, and cover a little bit about how to look at access logs in Kubernetes as well. Then we'll talk about Google's managed offerings for each of these services, before moving on to ways to configure Istio beyond its out-of-the-box telemetry and observability configurations for a little bit more control over what happens. So let's get started. So for the purpose of this demo, we are acting as the first SRE brought on to Hipster Inc. They were doing microservices before they were cool, which at this point I think was a while ago. If you've ever worked with Google's microservices demo on GitHub, you're going to be familiar with this application. We're going to be onboarding as an SRE and seeing what we need to change to make operations consistent and reliable for this application. So let's take a look at the application and get to know it. We've got an e-commerce application known as the Hipster Shop that's composed of, it looks like about 10, a few more than 10 different services written across 5 different languages. So it's a polyglot microservice mesh. And overall, I'd say this looks like it's in pretty good shape. You can see that the developers have left us a nice architectural diagram showing the dependencies between services and how traffic flows between them. We've also got links to the source code for every application or every microservice, along with its particular purpose in the mesh and the language it was implemented in. So there's a lot to be happy about. We've certainly seen microservice meshes handed off with a lot less documentation. This is looking like a great start. Nonetheless, there's still a little bit for us to be concerned about in this service mesh. If you look across the code base on the Hipster Shop, you're going to notice that we use bespoke metric names and definitions. This means that the way that we record error rates in one service might not be named the same thing in a different service. Also, just the meaning of an error might be slightly different from service to service. It makes it difficult to get a good apples to apples comparison across services. And so that's a little bit concerning. That's something we'd like to see cleaned up. This architecture diagram is great. I've taken over a lot of applications that didn't have anything nearly this detailed. But at the same time, we have no certainty that this architectural diagram is up to date. Services change all the time and their dependencies shift over time. And documentation like this often goes out of date as soon as it's written. So we'd like to have a way of measuring the de facto dependencies of these services to understand how closely this architecture diagram matches with the truth in our service mesh. And then lastly, troubleshooting cross-service issues is just hard. I don't know that this is necessarily something that is a deficit in the Hipster Shop. It's just challenging to understand when you see an error in a particular microservice. Is there a downstream error that's causing that? Maybe one of our dependencies is having difficulties. Is there something wrong with the upstream request that's coming into the service? It can be incredibly difficult, especially just using telemetry to troubleshoot this and then looking through logs. So we're going to see how we can improve on that for our application as well. Let's talk about the types of tools we can use to improve on that. We are going to be installing Istio in our service mesh. Right now, we have services that talk directly to one another. Once Istio has been installed, there will be this Istio sidecar in every application pod that intercepts all inbound and outbound traffic. Later on today, you're going to have a presentation that gets into a lot more detail on this process. But for now, all you need to know is that by intercepting all the traffic, Istio is able to annotate and to write telemetry and to write traces and logs consistently across all your services so that if you understand how to manage one, you'll have a much better idea how to manage all of them. We'll get that apples to apples comparison. As we install Istio, we're going to be following the instructions that are there linked on the page. Pretty simple, just a one-step process using the istio-cutl install command. I will give a caveat, though, that I'm using the demo profile. I'm also using some samples of Prometheus installs and Jaeger installs just for illustration purposes. these profiles are not meant for production use. We have production profiles that are available. We have documentation available on istio.io for how to integrate with your existing telemetry system. You really shouldn't be using our samples in production. That being said, they're a great way to kick the tires on Istio Service Mesh, which is what we plan to do today. So let's get started. The tools that Istio is going to be able to integrate with in terms of observability are many. In particular, with the advent of OpenTelemetry and OpenCensus, almost all of the modern observability tools out there on the market today are going to be able to integrate with those standards. And so these are just a few examples of integrations that we've documented on our website. You can check them out for details, but today we're going to be covering Prometheus and Grafana along with Jaeger and Kiali. Let's go ahead and get started installing those into our cluster. All right, so to get started with, we have an empty cluster here. I'll show you that we have no pods outside of the Kubernetes namespace installed here. Oh, gotta authorize my Cloud Shell. I'm using Cloud Shell for this demo. You can use any Kubernetes clients. So a bunch of kube system pods, but nothing running in default. There's no Istio system namespace yet. We haven't even installed our application yet. So let's go ahead and start by doing that. Go ahead and grab our first command, which just runs within the microservices demo project on GitHub, runs the Kubernetes manifests in the release folder. Give that a little bit of time to install. All right, looks like all of our services have been created. Now I'm going to run the Istio install command. And I'm going to be using Istio 1.10.3, which is the latest release at the time of this recording. All right. You'll notice I'm giving it a revision name of 1.10. We're going to have to use that a little bit later when we label our default namespace for injection. But let's go ahead and get our control plane installed here. This usually takes about 30 seconds. All this is doing is creating the Istio control plane. This is not going to change anything about how the traffic in my mesh is currently flowing. In order to do that, we want to explicitly tell Istio to begin managing and injecting sidecars into the deployments. And we're going to do that with a label. All right, so Istio 1.10 has finished installing. Now let's go ahead and instruct it that it should be injecting sidecars in the default namespace. So for that, I'm going to label the namespace with this Istio.io revision at that 1-10, just like we specified in our install command. Now, changing the label on the namespace means any new pods created in the namespace will be sidecar injected. But as you noticed, our application's already installed. We already have all of those pods running with no sidecars. So in order to do that, we need a rolling restart. So we're going to go ahead and rolling restart. We can ignore all this stuff at the end here. This is from a previous demo. Just like that. There we go. Third time's a charm. Now all of my applications are restarting in the default namespace. So the Hipster Shops pods are all going to be restarted. And as they restart, we will start to see that they have sidecars in them. We can check that by listing pods in the default namespace. Notice how the ready signal has 2 pods for most of our running containers. And the ones that only have 1, I'm sorry, that's the number of pods. I'm showing you the wrong thing. Let's grab one of these names here. Oh no, so sorry, we're looking at containers. So yeah, the ready number is the number of containers that are ready. And as our rollouts all complete, we'll start to see these all be 2 out of 2. That means that we are running the Istio sidecar along with the original container that was hosting our application. All right, and we're tearing down that last remaining pod that did not have a sidecar. So we now have our entire service mesh running on Istio. So what has changed? What's different? Well, from a traffic perspective, nothing. Your users shouldn't see any change. The services are still performing as they normally do. All of their dependencies are like normal. The difference is now we have a whole bunch of telemetry available that Istio can provide to a telemetry system. Unfortunately, as you saw, this cluster is empty, so I don't have any telemetry systems installed. I'm going to go ahead and use the Istio add-ons sample to give us a sample Prometheus install, sample Grafana, a whole bunch of stuff that gets installed here. Once again, not production quality, but great for kicking the tires on the Istio service mesh. And unfortunately, that often fails on the first run because CRDs take a little while to roll out on Kubernetes, so you tend to run it twice. Again, not production quality, just intended for demos. There we go. We can see those commands succeeding now. Great. So now I'd like to introduce you to a command that when you're running these samples will be hopefully a good friend, and that is the Istio dashboard command. It would be great if I could type Istio during a live demo. All right. So we'll just go ahead and run dashboard on its own. And basically, this is going to hook up to those sample installs and allow us to very quickly see what's going on in each of them and actually connect to them via port forwarding. So the first thing that we'd like to take a look at is going to be Grafana, which is pulling its data from Prometheus. So we're going to run dashboard Grafana. If you're doing this in your Cloud Shell, then you should just be able to click this link and with GCP magic be connected through to your port forwarding. If you're running it from an environment where you happen to have a graphical environment, it will open the browser on your behalf. So here's our landing page on Grafana. And if we have a look up here in our navigation bar, we have a folder full of Istio charts in Grafana. Let's take a look at our mesh overview. We can see the number of operations per second that are flowing through our mesh. We don't have any 500 response codes anywhere across the mesh at the moment, which is great. We did see a brief spike in 400s, but that appears to be over and intermittent. Might be something worth troubleshooting later on, but it's not enduring, which is always good news. And then we don't have any Istio configuration. This virtual services, destination rules, gateways, these are all custom things that you can add to your service mesh, and they will add value, but we're talking about Istio out of the box. So you're going to see NA for all of those out of the box because we've not configured any of them yet. But we can see each of our services and the amount of traffic that it's handling, the amount of latency, its error rates, a lot of interesting data right here on our mesh overview page. But let's say that we wanted a little bit more detail than we had. We could go ahead and go back to that folder and maybe have a look at an individual service within our service mesh. So we're in the namespace default, and let's look for service workload. Oh, it only gives us all here. Might take some time for these values to populate as our service mesh adds more and more data. Here we go. Here's the service dropdown I'm looking for. So we can look at how our cart service is doing in particular. We can see its traffic flow over time, its errors. Oh, looks like we had a little bit of a latency spike here. That might be worth investigating. That might be associated in terms of time with when the sidecar was installed, although the fact that we have data before tells me probably not. So that might be something worth looking into. Why are we having 400 millisecond P99 latency on that particular service? Again, the nice thing here is we have complete apples to apples comparison across all of our services. If I look at the payment service, I'm going to see exactly the same charts, exactly the same statistics. I don't need to know a whole lot about the payment service in order to look at its telemetry information and understand very quickly what our users are experiencing as a result of this service's operations. So a lot of value here out of the box for operations. And then if for any reason you're a little bit concerned about, not about your services and how they're performing, but about how Istio itself is doing, we've got our performance dashboard here. We're going to show the amount of CPU that our control plane is using, our memory usage. All of this information with tons of charts is available to you. And by the way, these are the same charts that we use to understand in our performance tests how the service mesh is performing. So we do make a lot of use of these, and we pay a lot of attention to how they're doing in each release. hopefully you'll find some value there for yourself as well. All right, so much for Grafana and Prometheus. Let's take a look at individual traces. You notice we saw a few of our requests had some pretty high latency spikes there. Maybe we'd like to understand what happened on that particular request. Prometheus isn't the right tool. Prometheus is going to give us aggregate statistics, but Jaeger is a trace span analysis tool that should be able to help us figure out what's going on here. All right, same routine. I'm going to click on the link. All right, so let's take a look at some traces for our cart service. Go ahead and click the Find Trace button, and we can see some trace spans. It illustrates the sort of latency that we're seeing just on these particular trace spans. It does look like latency climbed on the cart service, but not in a way that was concerning. Although our front-end service is the service that handles all user traffic at the beginning. If you remember that dependency diagram we saw at the beginning, let's take a look at the user's experienced latency. Now we're looking a little bit closer to 20 milliseconds here, but none of these spikes actually look terribly concerning. And it appears that that 400 millisecond spike that we saw in telemetry did not result in a trace span. So what's the problem here? Have we misconfigured Jaeger? Have we misconfigured Istio? Well, none of this is problematic, actually. By default, Istio is going to record only 1% of your requests to trace spans. Trace span recording adds a lot of latency to the request on its own. It adds a lot of overhead in terms of storage in the long run. And so we don't store everything on your behalf. There will be things that telemetry catches because it aggregates over 100% of requests that are not caught by default in these trace spans. Now, we are going to talk a little bit later about the APIs that you can use to change it to collect 100% of trace spans if you're interested. But just know that there will be a performance hit resulted with that amount of data collection going on in your service mesh. If we want to know a little bit about a particular request, we can click in, but you'll notice that by default, actually our trace spans, while they're interesting and can show us a lot about the latency of individual requests, I can even get into the details and headers of the particular request that I was dealing with. It's gRPC content type, that sort of thing. Normally, I would expect to see a lot more spans within a trace. I would expect to see the front end contacting perhaps the cart service, which maybe is contacting the checkout service, which talks to the Redis database, and each of those would be represented as a span here. None of that's coming through at the moment. And this is where we talk about the one area that Istio could use a little help out of the box. If you think about the way that the Istio sidecar works, we handle all inbound and outbound traffic for a pod. Well, when there's outbound traffic, Istio cannot by itself match it to an inbound request. You might be handling a dozen inbound requests at a time and have 10 outbound requests at a time, and we can't figure out which outbound request maps to an inbound request, which is what we would need to do in order to show those spans all being a part of this single trace. So in order to help us do that, we have a list of headers that we need you to propagate. Basically, when a request comes in, we will annotate it with a particular identifier header. And we need you to have all of the outbound requests also use that identifier header so that we can tie the trace spans together. There are multiple open census libraries that will do this for you. If you're using something like HTTP or gRPC across most languages, you can use open census for this, and you'll get all of this for free. The microservices demo applications don't do this, and so we're not going to see that detailed trace spans in Jaeger. So there's some value to be had here. There's some interesting information, but if we wanted to dig down deeper, we would need to change some of our code in order to get more information into Jaeger. All right, let's take a look at our last section of the demo here, and that is going to be Kiali. Kiali is a tool that it isn't exactly telemetry, and it isn't exactly trace spans. It sort of spans both worlds, if you will. And what I really liked Kiali for is understanding the dependencies between my service meshes. Kiali, by the way, none of these are part of the Istio project. These are just other tools that we integrate with. Kiali does a great job integrating with Istio, but we don't run Kiali ourselves. Let's go ahead. I love the graph view that Kiali provides. Remember that architectural diagram that we saw earlier, and I told you we wanted to check to see if it was correct? Well, this is where I would come to do that. For each of these steps, I can see the service name that's being hit, as well as the workload that is backing that service name for our users, and then the outbound dependencies. within a given dependency, I can look at its success rates. Looks like there's not much going on there at the moment. I can look at latency inbound and outbound by service. I can look at traces, which again, we mentioned are only 2 spans each at the moment. So those could be more useful over time. But there's a lot of data here available. There's also alternate ways to arrange and view the graph. So this is really a great tool that I encourage you to take advantage of, especially when onboarding to a new application like we're doing right now for the hipster shop. This gives me a great idea of where all of my dependencies are. If I have users who are experiencing too much latency, I can use this very quickly to begin to understand where that latency is coming from within my service graph. And then I can drill down into the trace spans to understand what is unique about the requests that are generating that latency in order for me to be able to go in and optimize or maybe make some recommendations to the development team on how they can improve. So this is the Kiali tool. Again, there's tons more that I won't cover here that Kiali does for you, gives you recommendations on how to improve your service mesh. But at a high level, absolutely love getting to know your service mesh using the Kiali Graph View and Istio. All right, so we've shown you how out of the box you can use these open source tools to really get to know your service mesh. Let's talk about a little bit about the managed offerings that Google has in this space. Sometimes you really want to get down to operating your service mesh, and you don't want to think about what it takes to productionize a Prometheus and Grafana install, or a Jaeger install, or how to handle your logs in production. If that's the case for you, we have Google managed products that are built on top of this open source technology and integrate well with Istio for you. Our cloud operations suite, formerly known as Stackdriver, will handle your telemetry, your tracing, and your logs all in one consistent spot. So check that out within Google Cloud Platform. We have an upcoming managed service for Prometheus, so watch for a press release about that. It's totally Prometheus compatible, and if you've been operating Prometheus and would like us to take it over for you, that's an excellent opportunity. And then, of course, we have Anthos Service Mesh, the product that I work on, which brings all these things together and will actually handle operating your service mesh for you. So installing and upgrading Istio is not something that you'll need to continue thinking about, and you can get down to worrying about operating your services. Like I said, all of these things are built on top of open source technology. If you want to run a completely free and open source stack, Istio works great for that. But if you don't want that sort of operational burden, we have options for you as well. The last thing I want to talk about is what happens when you want more than the basic telemetry, more than what Istio provides out of the box. Well, so we have lots of integrations that we support, lots of customization you can do, but today it's not that easy to do. We have multiple config maps across the cluster, the mesh config and proxy config that you might need to edit. Those have some sensitive information in them, so your systems admin might be a little bit hesitant to give you access to edit those at will. You also might need to edit some Envoy filters, which at this point are alpha support only. And there's no guarantee that those don't break during upgrades, which is a little bit concerning for some of our users. So in Istio 1.11, we've started a preview of the Telemetry API, which allows you to use a proper CRD to configure either on a service by service, namespace by namespace, or service mesh by service mesh basis exactly what shape and feel you want your telemetry to take. You can tweak names, you can suppress certain telemetry if it's too noisy for you. You can integrate with other telemetry providers like that open census stuff that we talked about earlier. This is in preview mode in 1.11, but you should see it in alpha in 1.12, which is due to launch in mid Q4 this year. So keep an eye on those release notes if you're interested in going beyond the basics with your service mesh observability. I hope you've learned a lot about how much you can accomplish with Istio out of the box to get to know your service mesh. For more information, follow the link at the top of the page and enjoy your Google Open Source Live. Thanks.